Hi, everyone. Thanks for joining me today for Chapter 1, Lesson 6, where we are going to talk about the least common multiple. Please start by putting your name, date, chapter, and section down on your skeleton notes. And for our learning target today, we have I can explain how to find the least common multiple of two or more numbers. Today, when we talk about least common multiple, I'll often refer to it as LCM. So it's another acronym. Just last section, we talked about the GCF in 1.5. So I'm going to put versus GCF. You really need to know the difference between these two. I'll tell you right now, it's a lot of students get these mixed up. Okay, so I'm going to show you a few different methods today on how to find the least common multiple. But what you need to be sure is that you can keep these two things separate from each other. They might seem like they're related a little bit, which they kind of are, but they're definitely different things. So you need to find a way to keep these two separate, right? So let's start by looking at a little bit of vocab and figuring out what the least common multiple is. So for our vocab today, it says multiples that are shared by two or more numbers are called, that would be common multiples. The least of the common multiples, so the smallest of the common multiples, is called and you got it, least common multiple. And again, I'll refer to that as the LCM, so I don't have to say that mouthful every time. You can find the LCM of two or more numbers by listing multiples or using prime factors. So there's a couple different ways to do that. I like to list the multiples normally if they're two smaller, easier numbers, but you could also use prime factors and factor trees like we've done a couple sections ago. And I'll show you how to do both of those. All right. So the first way here is that I'm going to show you is I'm going to use this big M for least common multiple. The example says using lists. I'll kind of show you how this is a list, and I'll show you another method, kind of another common list method. So what I like to do is I like to start out by writing my two numbers, 4 and 6, up at the top of my M, the two legs of my M here. And then when I'm finding multiples of these, that means, well, I need to take 4 times 1. I'm multiplying. 4 times 1 would give me 4. 4 times 2. 4 times 3. So on and so forth. So you're probably starting to see the pattern. 4 times 4. Oops, is not 4. It's 16. Talking and writing at the same time is sometimes tricky. If you look at the pattern here, I'm adding 4 each time because if you remember, repeated addition is the same thing as multiplication, kind of what I'm doing here. I could keep going. 4 times 5 will give me 20, and 4 times 6 is 24. I'm going to pause right there and go over to 6 and see if I need to keep going or not. Yeah, so now I need to do the multiples of 6. So 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, and lastly 6 times 6. So here are the multiples of 6. 6, 12, 18, 24, 30, 36. And here are the multiples of 4. 4, 8, 12, 16, 20, 24. And you could keep going if you needed to. We're going to stop here because I don't think I already see some common multiples. Let's look and see. Let's circle my common multiples. 4, no, they don't have that in common. 8, nope. 12, yes, they have 12 in common. Circle 12. 16, no. 18, no. 24, yes. They have 24 in common. And that's all the further I went here. So right here, just in this short list, I have 2 common multiples. Now remember, I'm looking for the least of the common multiples. So what is the smallest number that they have in common? Well, that would be 12. So the LCM of 4 and 6 is 12. 12 would be the least common multiple of those two. Okay? So you might ask, well, Mr. Gillis, do I have to draw this M every single time? No, absolutely not. That's just one method that I use, and it's a nice visual for you to be able to see. Sometimes some students like to write their least common multiple right here in the M. But I'll show you another way for the Oyos here. So let me do the first one to show you the other list method you can use. And then I'll have you pause for number 2 and 3. So you can do it this way: the multiples of 3 and the multiples of 8. All right, 3, 6, 9, 12, 15, 18, 21, 24. I mean, you could keep going, right? And the multiples of 8 would be 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. Let's pause here and see if we have any common multiples. 3, no. 8 is not common. 16, no. 24 is common. So the LCM of 3 and 8 is 24. Now, some of you might have caught on and said, oh, you can just take 3 times 8 and that'll give you 24. That will for sure give you a common multiple, but it's not always the least common multiple. So be careful on that. Don't just multiply these and think that it's the LCM. Yes, it's a common multiple, but not always the least common of them. All right, please pause. Do one of these 2 methods for number 2 and 3 to find the LCM for those 2 on your own. All right, the least common multiple for number 2 for 9 and 12 should give you 36. And the least common multiple for 6 and 10 would be 30. All right, let me know if you have questions on either of those. For example 2, now we're going to use another method. I'm going to give you one more way to find the least common multiple of 2 or more numbers. You might like this method better. I think for some bigger, trickier numbers, this method works pretty good. Okay, so it wants us to find the LCM using prime factorization. So remember when we did that, we made those handy dandy little things called factor trees. So let's make a factor tree for 16 and 20. So for 16, I have 2 times 8 I could do. 8 I could break down into 4 times 2. And then 4 I could break down into 2 times 2. Remember, you're looking for the prime factors. So 2 is prime, and the other numbers are composite, so I can keep breaking them down into different factors of each other. So the prime factorization is 2 times 2 times 2 times 2. For 20, I could do, 4 times 5. 5 is prime, so I'll circle it. And I could break down 4 into 2 times 2. Okay. So now I have my prime factorizations. For my hint, it says write the prime factorizations of each number. Okay, so for 16, it was 2 times 2 times 2 times 2. And for 20, it was 2 times 2 times 5. All right, so I've done that. Next, circle each different factor where it appears the greatest number of times. So my first factor that I have is 2. And where does 2 appear the greatest number of times? So in 20, it appears 1, 2 twice. In 16, it appears 1, 2, 3, 4 times. So I'm going to circle it there because it's appears here the greatest. I have another different factor, which is 5, and it just appears once here, so I'll circle it one time. All right, now that I have that done, I find the product of those circled factors. Okay, so in other words, then multiply. So I'm finding the product of these circled factors. So I'm multiplying my circled ones. So 2 times 2 times 2 times 2 we know is 16, right? And then I take 16 times 5. So 16 times 5 would give me a total of 80. So the least common multiple of 16 and 20 is 80. Now, could you have done that using the list method? Probably, but maybe it's not very easy to find all the multiples of 16, right? 16, 32, what comes next, right? It might take a while for you to think about that. So using prime factorization is just another way. It's not the only way, but sometimes it can be quicker. I'll do one more of those examples here with you just to make sure that you have the hang of that. And then I'll let you try 5 and 6 then on your own. Okay? So first, start by making the factor trees. So 14 and 18. 14 would be 7 times 2, and both of those are prime numbers, so I can stop right there. And 18, I could do 6 times 3. 3 is prime. And then I could break down 6 into 2 times 3. And those are both prime. So again, then I'll write out the prime factorization. So 14 is 2 times 7, and 18 is 2 times 3 times 3. And then I'll circle the different factor where it appears the greatest. So 2 would be my first factor. It appears once in both 14 and 18, so I just need to circle it once. 3 appears twice in 18, so I'll circle it twice. And then 7 appears once here. And remember, you're circling each different factor the greatest number of times. So once I've done that, then I multiply those circled numbers. I find the product of those circled factors. So I take 2 times 7, which would be 14, and then 14 times 3, and then that times 3. So let's do a little bit of math here. 2 times 3 is 6. 6 times 3 is 18. And then 18 times 7, let me just write that down quick. 56, carry my 5. 7 plus 5 is 12. So the least common multiple of 14 and 18 is 126. Now, think about if you were to do 2 lists for 14 and 18, the multiple way of using lists and writing down the different multiples, that would take you a while to get to 126 for both of these numbers. And I just did it could probably do it in under a minute doing the prime factorization. So a little bit trickier, but once you get the hang of it, it really does work well. So pause and try the factor tree, the prime factorization method for numbers 5 and 6. Alrighty, for number 5, you should come to 252. And for number 6, you should arrive at 360. So if you didn't get that, please let me know or ask a friend to figure out how to do those ones correctly. All right, in example 3, it now asks us to find the least common multiple of 3 numbers. And you can do this either way now. You have a lot of different methods. You could do the list method. You could do the special M method. You could use prime factorizations. And I'm actually going to use prime factorizations because A, I think it'll help you to see it again. And B, when I have 3 numbers, making a 3 list now could get lengthy. whereas if I use the prime factorization method, it might be a little bit quicker. So factor tree for 4 would be 2 times 2, and I'm done. Factor tree for 15 would be 5 times 3. And factor tree for 18 would be 6 times 3 and 2 times 3. And then these are prime, right? These are all prime, so I can be done factoring. Now I'll make a list. So for 4, I had 2 times 2. For 15, I had 5 times 3. And for 18, I had 2 times 3 times 3. Okay. Remember, the trick here is to circle each different factor where it appears the greatest amount of times. So I'll start with 2. Where does 2 appear the greatest amount of times? Well, here it appears twice, so I'll circle it. And then I don't have to worry about this 2 anymore. 3 appears twice here, so I'll circle both of those. It only appears once here, so I don't circle that. And then my last is 5, and it appears once here, so I will circle it. And now I have all my factors circled. Now I'll multiply my circled factors. So 2 times 2 is 4, times, 3 times 3 would be 9. So 9 times 4 would give me 36. And then 36 times 5, that gives me 30, carrying my 3. 15 plus 3 would be 18. 180. So the LCM of these 3 numbers is 180. Now think about that. If you list all the multiples of 4 and you had to get all the way to 180, boy, that's going to take you a long time listing factors. So the prime factorization method worked very well for me there. All right, go ahead and pause for these 3 on your own. So hopefully you're starting to get the hang of it for 7, 8, and 9. Number 7, least common multiple is 40. Number 8, the least common multiple is 60. And then for number 9, it was a little bit more of an open-ended question. It says, write a set of numbers whose least common multiple is 100. So you have to be careful on this one. But if I'm thinking about 100, I'm thinking that's similar to $1. If I break down $1 in quarters, I'm going to think about it kind of that way. So I could have 25 cents. I could have 4 quarters are 25 cents and is also $1. And another number that would work, that's a factor of 100 would be 10. Okay, so let's see if that makes sense. Multiples of 25, so it'll be 25, 50, 75, 100. So, yep. 4 times 25 would give me 100, and 10 times 10 would give me 100. So, this is one set of numbers that would work. Now, it's not the only one. So, you might have something different. Maybe check with me or double check to make sure that makes sense. Now, what if you would have put 2, 10, and 25? Would that work? Well, the quick answer is no, because 2 is, because the least common multiple of these 3 would be 50, because 25 times 2 is 50, 10 times 5 is 50, and 25 times 2 is 50. So this least common multiple would be 50. So that doesn't work. But maybe you had a different one that did work. Let's move on to the last example here of the day for the real life application. And it talks about stoplights. And some stoplights work like this, where they're on a timer. So it says a traffic light changes every 30 seconds. Another traffic light changes every 40 seconds. Why do you think that traffic lights would change on different amounts of time? Think about that for a second. Well, one reasonable answer might be that one road is busier than the other road, like at an intersection where you might see traffic lights. So one is changing more frequently. The question says both lights just changed. After how many minutes will both lights change at the same time again? So we're talking about seconds here, and our answer wants it in minutes. So just realize that. Store that one in the back of your noggin there for a second. But you've probably caught on by now, and you can probably already see, all right, we need to find the least common multiple of 30 and 40. Okay, both lights just changed. How many minutes will they change at the same time again? All right, so this will be the multiples of 30 will be 30, 60, 90, 120, 150, 180. We might have to keep going. I'm not sure yet. Factors of 40 would be 40, 80, 120, 160, 200. And remember, we're talking about seconds here. So let's check and see. Do we have a multiple that is, do we have a common multiple now? Let's look. Oh, I see one, 120. And that's definitely the least. So the least common multiple is 120. And remember, that's in seconds. And this says after how many minutes? Well, if there is 60 seconds in 1 minute, that would give us two minutes. Okay. So both lights will change again at the same time after 2 minutes. Alrighty, that does it for 1.6 and the least common multiple. Again, please try to review this, especially when it comes test time, of the difference between LCM and GCF, because a lot of kids can forget that. Let me know if you have more questions, and I will see you guys next time.